Relations and graphs. Now, relation is a set of ordered pairs. So we have ordered pairs, or we can say it is values, or what we usually use is the word variables. Now, these have to have some relation. They relate to each other in some way. Let's look at the following example. So here we have a table that shows us the number of hours for renting a trailer. When I rent this trailer, for 3 hours it's going to cost me $50. For 4 hours, pardon me, it's going to cost you $60, 5 hours, $70, etc. These will be ordered pairs, so 3 and 50, 4 and 60. But we can also call these then variables, as the number of hours can change. So the variables will be number of hours and the cost will be variables. Now, it's important for me to know that there's two kinds of variables here. The one is dependent and the other one is independent. Now, the cost, what you will pay, will depend on how many hours you have it, which means that I'm going to call the cost the independent value. So this will be the independent value. Oh, sorry, that's a lie. This will be the dependent value. The cost depends on what is the number of hours, which makes the number of hours the independent variable. So that's the first thing that we have to get right. Independent, the number of hours will happen. The cost will depend on how many hours you have these. So independent variables and dependent variables. When I draw a graph, the graph gives me a visual of how this relation looks like. Now, the first thing before I'm going to draw the graph is I want you to remember the following. When I have a graph on my x-axis and my y-axis and my x-axis, I always have my independent values on my x-axis. So the independent variables, and how I remember it is, if I'm going to have a D and an I, the independent, I dot my I on the graph. Dot your I on the graph, which means if I put my I there, if I put my I down here, I won't be able to dot my I on the graph. If I dot my I for independent, I have to plot it on the graph, and therefore I call this my independent, and this will be my dependent values. So independent on the X, dependent on the Y. That's how I remember where to put which one. So if I have to draw a graph of this, this is what I will do. So on my graph, I'm going to have my independent value. My independent is the number of hours, which is the number of hours. And my dependent variables is on my y-axis. So X, Y. And what I'm going to do is I'm going to say when the number of hours is 3, this is 50. 4, 60. 5, 70. 6, 80. 8. I missed something. 50, 60, 70, 80, 90, 3, 4, 5, 6, 7. 50, 60, 3, 4, 5, 6, 7, 8, 70, 80, 90, 100, 50, 60, 70, 80, 90, and 100. Now, what we usually did then is we just drew a line through there. And this is where our next concept comes in. I cannot connect these points because we are paying for the number of hours and we don't pay part hours. So I can only have dots here. I can't connect them with a line because a graph always tells us what is all the possible answers for here, so I can make predictions. Now I can't go to 3.5 hours and say that is $55 because there's nothing in between. The function or this relation, there's no relation in between those points. And this brings us to our next thing. When I have values or variables, there can be two types of variables. The first type of variable is going to be discrete and the second one is continuous. Continuous dependence. Right, and the difference between these are the following. Discrete are the ones that we can count. So it's usually whole numbers, or it is with nothing in between. Shoe size can be discrete values because you get 9, 9.5, 10, 10.5, but you can't have 10 3/4, which means that there's only specific values. Discrete, there's nothing happening between values. So discrete variables and continuous. So these are usually countable, and continuous values are measured ones. Things you can measure. And then we're going to have a line in between, because when I have a y and an x, and this is, let's say, time, and this is height. At any time, you can measure the height of a tree. Okay, so that's the difference between discontinuous and continuous values. If I have discrete values, on discrete values, I will have only dots. On a continuous graph, I can have a solid line. The next thing that we're going to have is my relation can be given as an equation. I can have a relation written as an equation. So in this case, if you look at this, I can write the following. I can say that for this relation, that the number of hours or the cost, remember the cost, I'm always going to calculate the cost because the cost depends on the number of hours. So the cost, what I will have is the number of hours, 3 hours, 3 times 10, it's 30 plus 20, 4 times 10, plus 20, 5 times 10 plus 10. So I can say the cost will be the number of hours, T, multiply by 10, which gives us 10T, and then I'm going to add 20. Now we'll come back to these later of how to get this, but look at what happens if I put the value in. 3 times 10 is 30, plus 20 is 50. 4 times 10 is 40, plus 20 is 60. 5 times 10 plus 20 is 70. So this will be then the relation that tells me how to do this, and the graph can be represented by this value. Now remember, sometimes we can't have, in this case, we'll have to say that T is whole numbers. And this will bring us to a whole new concept. In the next video, we will look at sets of numbers, because sometimes the numbers can only take certain values.